Let's talk about polyrhythms. Finding out how to implement every form of that thing is a simple math. Here is how. I love polyrhythms and always have. When I was a kid, I commuted a lot using the bus service. Back in those days, the buses had separate motors for the windshield wipers. The two of them went in a polyrhythmic pattern. To kill time when waiting for the bus to reach my stop, I often tried to count out how many swipes the left wiper went until both of them synced up, for example, when both landed on the left together. Then I counted out the frequency of the one to the right and worked out the differential ratio. The same went with church bells. In the town I grew up in, Kópavogur, there are two bells in the bell tower and they are not synchronized. Often the higher pitched one went, let's say, 20 times, when the darker one went 19 times. They sounded together for a brief moment, then drifted apart and finally caught up with each other. I listened and counted and went into a dreamlike state of flow doing so, a state of happiness. In my last episode, I taught how to find out several tempos using 3/2 polyrhythm. But I know many of you have no training in working with this phenomenon. That is all about to change now. Let's look at 2/3, 3/2, 4/3, 3/4, 5/4, 3/5, 4/5, and even 4/7 just for fun. This has everything to do with subdivision of a musical bar. Whether it is 4/4, 3/4, 12/8 or whatever. When something is implemented over 3, it means that the bar we are working with contains 3 beats. A 3/4, for example. Now multiply the numbers of 2 and 3 together. You get 6. 6 is the number of how you divide the polyrhythm over the bar length. So when finding out 2/3, you superimpose 6 possible slots over the 3 beats of the bar. Each beat gets 2 possible slots. For that, we see that we will be working with 8 notes in this instance. Every polyrhythm starts with stroke on the first slot. To spread 2 strokes evenly among 6 slots, you simply place the next stroke 3 slots apart from the first one. Now let's try the same with 3/2. The latter number here tells us there are only 2 beats in the bar. And so the bar type is, for example, 2/4. Again, we multiply the 2 numbers together and get 6. Therefore, there must be 3 slots for every beat. We are working with triplets here. Notice that the number of possible slots per beat is the same number as the former digit in the name of the polyrhythm. And we do not need to multiply the numbers together again, but only remember that the former digit tells us the number of possible slots per beat. And the latter number tells us how to place the polyrhythmic notes apart, 2 slots apart here. 4/3 means we are working with 3/4 and possible slots of the polyrhythmic notes are 4 per beat, hence 16th notes. And we place them 3 notes apart, as the latter digit suggests. 3/4. 4 beats in the bar, 4/4, and 3 slots per beat, aka triplets. And we place them 4 notes apart. 4/5. Bar of 5/4. We are working with 16th parts in the upper voice and place the note 5 slots apart. 3/5. A bar of 5/4 with triplets on top placed 5 slots apart. 5/4. Now here is a difficult one to play. Can you see why? The answer is that the slots of possible polyrhythmic notes are 5 in every beat. Most of us are most likely not used to dividing beats into 5 slots, but if you want to try this, just place each note of the polyrhythm 4 slots apart. Lastly, 4/7. It is so much easier to divide each beat of 7/4 bar into 16th note than there is to divide each beat of a 4/4 into septuplets. So here goes. Write out a kick drum note at each beat of a 7/4 bar and divide the snare voice into 16ths. Place a note in every 7th slot and Bob is your uncle. There you go. Polyrhythms are like gear ratio, though we do not consider the ratio of 2/1, 4/2 and 6/3 to be polyrhythms because it is a clear subdivision of beat lengths, just like 2 eighth notes are just a quarter note split into 2 halves. Evenly placed 3 strokes against 4 beats in a bar, it's much more interesting because it forces you to work things out.